Hey guys, today we're going to continue with completing the square, and we'll really work on some problems here where factoring is not going to work out for us. So we're going to jump right in, try some problems out. We have x squared plus 14x minus 38 is equal to 0. And you can go ahead and try to factor, but factoring is not going to work here. So that means we're going to have a different type of answer. The numbers aren't going to be quite as nice as if we could use factoring. So let's go ahead and go through our method of completing the square. X squared plus 14x, I'm going to bring the 38 over to the right side. And now let's go ahead, just keep going. Complete the square. Half of 14 is 7. Square it, it's 49, so that makes a perfect square. Over on the left side, on the right side, you have 38 plus 49. When you simplify that right side, you should end up with 87. Notice that's not a perfect square. We're still going to use completing the square though. So here we're going to end up with x and plus 7. And that whole quantity is being squared. So now when we're using completing the square, our next step is going to be to take the square root of both sides. So you end up with x plus 7 over here equals plus or minus. And I'm just going to leave it as the square root of 87 because that's not a perfect square. But this leaves us with two possibilities here. You could have x plus 7 equals square root of 87, the positive version, in which case x equals negative 7 plus the square root of 87. Or you can have x plus 7 equals the negative square root of 87, in which case x would equal negative 7 minus the square root of 87. Oh, just like that. So that means we have two solutions here, and they are negative 7 minus the square root of 87, or negative 7 plus the square root of 87. We'll leave our answers in radical form like this, so we have the exact value. You might see in the future, teachers may ask you to get a calculator and evaluate these out. I will have us leave them like this. So this will be our final solution here. Negative 7 minus radical 87 and negative 7 plus radical 87. Alright, let's hop on to the next one. See, these answers aren't quite as nice as yesterday, but they still are the values that we're looking for. Let's go ahead and jump into our second one. We have x squared minus 12x plus 25 equals 2. And we want to solve for x here. So we can't factor. We can try, but believe me, you can't factor for this one. So I'm going to bring the 25 over, making it a negative 23 over here on the right side. Let's go ahead and complete the square. So completing the square would mean take half of your b, so negative 6, square it. So you're adding 36 to make this a perfect square, but then you also have to add 36 to the right side. When you simplify that right side, you should end up with 13. On the left side, we made this a perfect square so that we could write it like this. Now we're going to go ahead and take some square roots. So take the square root of the left, you get x minus 6. Take the square root of the right, you get root 13. And you're going to have plus or minus. And I'm going to move everything over so we have x isolated. So you have, when you add 6 to both sides, you have 6 plus or minus the square root of 13, which means you really have two scenarios. You have 6 minus the square root of 13, and you have 6 plus the square root of 13. Those are your two possibilities here. So those are your two solutions. And just like that, you're done. Answers are a little bit messier, but they are still the values we want. We're going to try two more and look at some other scenarios here. So our next one, we have x squared plus 4x plus 10 is equal to negative 5. So let's go ahead and complete our square. In order to do that, we need to get the 10 over. So we'll have negative 15 over here. Take half of your b term, half of 4 is 2, squared is 4. So we have x squared plus 4x plus 4 equals negative 9. Over here on the left side, we'd have x plus 2 squared equals negative 9. When we try to take the square root, we're going to realize you can't take the square root of a negative. We don't know how to do that yet. You'll learn that in the future. But right now, since we can't take the square root of the negative, it's not possible. We're going to say there's no, keyword here, no real solution to this. And that's what we're going to leave our answers as for now. So when you do completing the square, when you isolate the left side and get it to a perfect square, if on the right side you have a negative, that means you're going to end up with what we say is no real solution. You'll learn about how to do those when you get into Algebra 2. Alright, and our last one of the day, we have 3x squared minus 9x minus 3 is equal to 21. So one thing I notice, every single term in this is divisible by 3. To complete the square, we want that a to be 1. So I'm going to divide everything by 3. So you'll have x squared minus 3x minus 1 is equal to 7. I'm going to move that 1 over. So we'll end up with x squared minus 3x is equal to 8. And now we're going to complete the square. So to complete the square here, we're going to have x squared. Well, notice we don't have a nice even number in the middle. That's okay. Half of 3, just write it as 3 halves. And you're going to square that. So when you square this, you're going to end up with, well, 3 squared is 9, 2 squared is 4, so you're going to end up with 9/4. So your plus c would be plus 9/4. Not the nicest number, but it's what we have. So you're going to add 9/4 to both sides. And we're going to run out of space, so I'm going to reset at the top here. So let's go ahead and take our x squared minus 3x plus 9/4. Over on the left side, 8 is the same thing as 32/4. So 32/4 plus 9/4 would be 41/4. And we'll leave it like that. So when we completed the square, we took half of the b term, which was minus 3 halves. So that's what's going to go inside the binomial, and that's what we would square to get this. And over here on the right side, we're left with 41/4. Kind of messy. Let's go ahead and take the square root of both sides though. That's the whole purpose of completing the square. So take the square root of x minus 3 halves squared. You're going to end up with x minus 3 halves. Take the square root of this side, plus or minus square root of 41 over 4. To take the square root of 41 over 4, you have the square root of 41 over the square root of 4. You might notice you can evaluate one of those. You can't evaluate the top, so plus or minus square root of 41. But you can do the bottom. Square root of 4 is 2, so we'll have 2 down here. And now we're really close. Let's get x by itself. So x equals, we're going to add 3 halves to both sides. So 3 halves plus or minus square root of 41 over 2. Notice we have a common denominator, so we can combine it to look like this. X equals 3 plus or minus square root of 41, all of that over 2. And this is actually going to be a form that we're going to become very familiar with pretty soon. It's how we use something called the quadratic formula. A lot of the time we end up in this form. But in this right now, we have 2 scenarios. You have 3 minus the square root of 41 over 2. And you have 3 plus the square root of 41 over 2. Those are your 2 solutions for this equation. Really messy, but still, those are the correct answers here. So completing the square, this will be our method now. If we can't use factoring, you can fall back on completing the square. Sometimes the answers get a little messy, but with quadratics, your solutions are not always really nice numbers. Alright guys, that's all we have for today. Have a good day.